Alright, this video will go through a couple of the questions that you guys had from class today. Part 8 from that worksheet called Newton's second law has this vehicle accelerating, so it gives us the mass is equal to 1.08 times 10 to the 3 kilograms, and it says it's accelerating uniformly for 12 seconds, and it gives us the distance that it covers. So the distance is 132 meters. Okay, so basically what this question does is combine what we did with our kinematic stuff before and now this new dynamic stuff. So we're going to use some of our kinematics equations and the information given here to come up with what the acceleration is. If we know what the acceleration is and we know what the mass is, then we can use Newton's second law of F equals ma. So basically we don't know what the final velocity is. We do know what the initial velocity is. That would be 0 because it says it starts from rest, so 0 meters per second. We know what time is, we know what the change in distance is, and we are trying to find the acceleration. And so the formula that we could use, if you look at your chart on page 53, would be the one that doesn't have the VF in it. So that's going to be this one here, how delta D is equal to VI delta T plus half E squared. Okay. And we know that VI is equal to 0, so this term ends up canceling off. And we're trying to solve for A here. Okay, so we're going to end up with a formula that works out to 2 delta D divided by T squared should give us what A is, right? So when we plug that in, 2 times 132 meters over 12.0 seconds squared. Do that in your calculator a sec. I'll just do that. 2 times 132 works out to about 1.83 meters per second squared. Okay, if we go back up to here, so we have F is equal to, right, the question's asking for that net force, so that's going to be our mass, 1,080 kilograms, times this acceleration should equal 1,980 newtons, which is the right answer. Okay, so all of these questions, there's a real possibility that you'll end up using some of your kinematics equations already. That's why we did kinematics first. So any of those equations that you used, those are fair game. So just a couple hints. I'll let you work out through numbers 9 and 10 on your own, but I'll give you a couple hints on them. Number 9, it's kind of the same idea. You know the acceleration, or you know that there is an acceleration. You know that you have the distance given, you have your two different velocities, right? So you need to use the equation that doesn't have anything to do with time in it, right? And use your VI, VF, your D, and use that to find what A is. Once you know what A is, multiply that by your mass, and you'll be able to get your force. 10 and 11, similar type things, right? You're given, and number 10, you're given the force now. So using that force and being able to figure out the acceleration with that time, you should be able to work backwards then to figure out what the mass is. Number 11 is looking for a distance, right? So if you know what the force is and the mass is, that should be able to give you what your acceleration is, which then you'll be able to work back using your kinematics equations to be able to come up with a distance and then a time as well. Okay, you had a question on number 1 as well from the other one. Let me just look at that question. Okay. Okay, there you're given the force and the mass, so you should be able to just work backwards to find acceleration there, right? Divide force divided by mass. So, that one should be fairly straightforward too. So, hope that helps. If you need a little bit more help, let me know. Okay, enjoy your weekend.